Hello, grade 7. Welcome back to teaching math, or learning math, whatever you want to call it. We're moving on to 4.8, which has to do with the area of a parallelogram. And again, I've shared with you the learning goals, and I thought right off the bat I would share with you the formula for an area of a parallelogram. So our first learning goal is to be able to develop the formula A equals B times H for the area of a parallelogram. And secondly, once we have developed that formula, is to calculate the area of a parallelogram. Probably not just one parallelogram, probably a few more. What I've done is I have made out 3 parallelograms. Parallelogram 1, parallelogram 2, and parallelogram 3. What I'm going to do on each of them is I'm going to draw a vertical line from one part of it to the from one line at the top to the other line. Now, just maybe a bit of history. Parallelograms are quadrilaterals that have 2 sets of intersecting parallel lines. So that means that not only do you have parallelograms that look like this, but rectangles and squares are also technically parallelograms. But when we talk about being the most specific in our answer, we can say that they're parallelograms, but a square or a rectangle is a more specific answer. Now, to get back to it, what I'm going to do is I'm going to again draw this vertical line from the top to the bottom. And I'm going to do that on each of them. Then what I'm going to do is I'm going to take the parallelograms and along the line that I've drawn, I'm going to cut that, what's going to become a triangle. If my scissors will let me cut nicely. I'm going to cut that piece right off, and I'm going to move it to the other side so I create new shape. Oops. There we go. And so what I'm doing is I'm basically turning these from sort of traditional looking parallelograms, and I'm turning them into something that we're a little more familiar with, which is a rectangle or a square. In other words, shapes that we know how to calculate the area. Okay, so now I've gotten these 3 rectangles made out of my 3 parallelograms. And what we're going to do is I'm just going to be looking for how long the length is, which in this case is 1, 2, 3, 4, 5, 6 units, and then along the side here it's 1, 2, 3. And so I can actually calculate the area of that shape because I know that it's A equals L times W, which is, we do our substitutions, 6 centimeters, times 3 centimeters, which gives me an overall area of 18 centimeters squared. Now again, with this one, with number 2, the length is 1, 2, 3, 4. The width is 1, 2, 3, 4. So I'm actually working with a square here. So again, L times W, which is 4 centimeters times 4 centimeters, which equals 16 centimeters squared. And again, number 3, same thing. It's a rectangle. It's 1, 2, 3, 4, 5, 6, 7 long, and 1, 2, 3, 4, 5 high. So its area equals length times width, and it's 7 centimeters times 5 centimeters, which equals 35 centimeters squared. Now, if I rearrange these back into parallelograms, and I think, well, what measurements did I use to calculate each of these areas? Because the area doesn't change just because I rearranged them. The area of number 1 is still 18 centimeters squared. The area of number 2 is still 16 centimeters squared. And the area of number 3 is still 35 centimeters squared. What we've done is we've looked along the bottom line, this baseline, and then we've also looked along sort of the distance between these 2 lines. Now what this becomes known as, if I can just draw out a quick parallelogram, this is a really rough one, but this becomes known as our base, and then this dotted line becomes known as the height. Now we represent the base with a B and not H, or sorry, a height with an H. So we end up being able to use this as our formula. Area equals the base times the height. I'll try and get that a little closer for you guys. Area equals the base times the height. Okay? So with number 1 here, instead of writing L times W, what we could write is B times H. Right? The base is 6 centimeters, the height is 3 centimeters. Okay? Same thing here. We could have written A equals B times H. Base is 4 centimeters, height is 4 centimeters. Number 3, the base is 7 centimeters, and the height is 5 centimeters. Now, what this leads me into is this. Sometimes you'll see parallelograms that look like this, where this dotted line, which is going to be our height line, is included inside the drawing. Sometimes it's not. Sometimes you're going to end up with a drawing, with a diagram rather, that looks like this. And you'll see a parallelogram that looks like this, and then way outside here, there will be dotted lines sort of extending to form a 90-degree angle. And then you'll be given a dimension here. Let's say this is 2 meters. And then you'll be given a dimension here. Let's say this is 6.4 meters. Now, you do not need to measure this line or this line to calculate the height. Okay, the height is the distance between this line and this line, which we said is measured out at 6.4 meters. So to figure out the area of that shape, what we do is we use our formula. A equals B times H. And our base is 2 meters, and our height is 6.4 meters. And so when we do that multiplication, we end up with a total of 12.8 meters squared. So I'll just rearrange these again for a second. So these are sort of, these ones up at the top here, these are like the traditional parallelograms that you will notice. These ones over here. And then this one is sort of a non-traditional one where the height dimension actually comes outside of the shape. Okay? Now sometimes you'll see one that actually has 3 numbers, where this line will have a measurement. That is meant just to see how well you understand where to get the numbers from. Okay, so please make sure that you don't use this sort of diagonalish line, that your base number and your height number are the correct numbers. I think that's probably all for now. And so if you have any questions, we can take it up in class. So have a great day.